I was teaching you modulus of a complex number. So let's look at the diagram. Whenever I want to plot a complex number, how do you plot it? I explained to you last time.
Yes, sir.
Imagine this is the complex number a plus bi, which means the distance from origin to this point P is the modulus. This length is the modulus. And we know that if I draw a perpendicular here, this point corresponds to A comma B. So this is A and this is B. That means this is also B from here till here. So OM is A, BM is B. So OP square is OM square plus BM square by Pythagoras theorem. So OP square is A square plus B square. So the length OP is root of A square plus B square. So the modulus is obtained by root of A square plus B square. This everybody knows.
Yes, sir.
Now I also told you what you mean by argument of Z. What is the actual geometrical meaning of argument of Z? How much should I rotate? How much should I rotate from the x-axis to reach this
To
point
reach the
P?
other point.
Whatever the angle of rotation. If you rotate it clockwise, anti-clockwise direct, you take it as positive. If you rotate it this way, you take it negative. So the angle through which you have to rotate is called the argument. So if I'm calling argument of Z as theta, what can you say? Sin theta is opposite side by hypotenuse.
Sir, but negative argument was not taken till now, no?
Yeah, I'll tell you, I'll explain. That depends on how you take. You can, it is your option to rotate this way or to rotate this way and come to this
Okay.
point. Yeah. But I'll tell you something after that. Cos theta is equal to B upon root of A square plus B square. So if I give you a complex number, how will you, how will you decide what is the argument and what is the modulus? Formula to calculate, actual formula to calculate argument is tan theta is B by A. We use always tan theta to calculate the argument. All right. So this formula, whatever I have written here, is applicable only if the point is in the first quadrant. If the point goes to second quadrant, you got to always measure in your textbook and in your syllabus, always you have been measuring in this direction. But depends on book to book. You can also measure this direction. Some other book may give you argument as negative number. But in your book, in your textbook, if you want your answer to tally with whatever the answer given there, you got to rotate only in one direction. So I'm going to teach you only in one direction. Is it clear?
Yes,
so let's
sir.
have a look. Let's have a look. So first point, if the complex number A plus IB lies in first quadrant, what is the formula to calculate the argument? Argument or amplitude. So your complex number is Z is A plus IB. If A is positive, B is positive, then Z will lie in first quadrant. Z will lie in first quadrant. If Z lies in first quadrant, your diagram will be like this. Then this is the angle that you're talking about. So your argument tan theta will be B by A. And theta is obtained by the formula tan inverse of B by A. Do you understand this notation?
Yes, sir.
Suppose tan 60, you know, is root 3. So if I write tan inverse of root 3, it means what is the angle for which tan's value become root 3? What is the angle for which tan's value become root 3? That is 60.
60.
So
60.
tan can be transferred to this side. So you write tan inverse root 3. Did you follow that?
Yes, sir.
Yes,
So
sir.
this is a formula to calculate the value of the argument if the complex number lies in first quadrant. If the complex number lies in second quadrant, let's see what will be our formula. You got to make this table, but after I complete. So Z lies in second quadrant. In that case, A will be negative and B will be positive. Then Z will lie in second quadrant. If Z lies in second quadrant, my diagram would be like this. This would become A plus BI. And my argument theta will be this angle. So what I do is, you know that A is a negative number, and tan inverse of a negative number, the negative comes outside. I'll tell you the explanation of this. What is tan inverse of minus root 3? Minus will come outside. It becomes tan inverse root 3. That will become minus 60.
Minus 60.
Understood? So if I want to calculate this angle, I have to do this method. Theta will be from 180 degrees, I must subtract tan inverse B by A. Now tell me, is it addition or subtraction? Here what I have written. What is this written? Addition, no?
Yes, sir.
But B is a negative number. Because B is negative, it will come outside and it will become subtraction and you will get this answer. So what is the formula for second quadrant? 180 plus tan inverse B by A. When I explain with the problem, you will understand, but let me complete all the 4 cases. Now, when we go to the third quadrant, in third quadrant, Z is A plus BI, A is negative and B is negative. Then Z will lie in third quadrant. Z will lie in third quadrant. In that case, my diagram would be like this. This will be A plus BI. In that case, I have to do like this. This much is 180. This much is tan inverse B by A. So your argument theta will be 180 degrees plus tan inverse B by A. Now tell me, is B by A positive or negative here?
Sir, it's negative now.
Negative.
B is negative, A is negative. So negative upon negative will become positive.
Positive.
Automatically angle will be 180 से ज़्यादा होगा, 180 plus. इधर B negative है, A positive है, इसलिए A negative होगा और negative बाहर हो जाएगा, इसलिए 180 से कम हो जाता है. Automatically. B और A का value अपने आप उसको will take care of that. We don't have to break our head.
So even by seeing the figure, we can say that it is less than 180 or more than 180 now.
Yes, yes. In always when it is in third quadrant, the argument will be more than 180. So use this formula, you'll get the argument.
Yes, sir.
Okay. Now we come to the last case. That is when in fourth quadrant. How do you decide it's a fourth quadrant? A is positive and B is negative. So Z will lie in fourth quadrant. If it is in fourth quadrant, my diagram would be like this. This would be A plus BI. Since we are rotating all in one direction, now I need to subtract from 360 degrees. The whole thing is 360 degrees. So argument theta will be 360 degrees plus tan inverse B by A. Don't have to worry about plus because
it will
B
be
is
converted into minus.
Yeah, this calculation is negative, that will come out. So 360 से subtract हो जाएगा. Did you understand?
Yes, sir.
Now, different books will give you, in some book will give you tan inverse B by A alone. This is a negative angle. So automatically it will rotate in this direction. So different books will give different answers here. Your textbook are following this answer. So I am also going the same way. Anyhow, remember, if you measure this way positive angle, if you measure this way negative angle. So whatever the answer comes, it's not a problem to you. You can easily understand whether it's positive or negative. I just went by your textbook. All of you understood this?
Yes,
Do you
sir.
want time to copy
Yes,
this?
sir.
Do you want time to copy?
Yes, sir. One second.
Yes, sir.
Yes, sir. Once.
Then I'll pause for a minute. For the JE purpose, you will be taking the argument as from minus 180 to 180. In that case, the first quadrant is tan inverse B by A. Second quadrant also no change, 180 plus tan inverse B by A, because they both are positive only. Now third quadrant, this is minus 180. So minus 180, this way rotation, minus 180. From that you must remove this, and that is tan inverse B by A. So here tan inverse B by A is positive number. Minus 180, if you remove a positive number, you will get this angle. This way the angle. I'll just mark it with some other color. This way the angle. This is a negative angle. And the last one, you want this angle, then it is minus tan inverse B by A. Automatically it will take care. So in this case, this will be a negative number. This will be a negative number. This will be a positive number. This will be a positive number. So it depends on how you want it. Accordingly, we'll have to take. So in JE, they give you option. So you can easily come to know which quadrant it lies, the position is correct or wrong. So you'll be able to do it easily. But both the answers are correct. Depends on the textbook, they follow different answer. In our college, use any method, I'll give you full marks. Okay? Because both are correct. Now we'll practice problems. How to calculate.
1 minute.
Yeah. So the complex number is in first column. The sketch Argand's diagram in the second column. What is the argument if it is 0 to 360? What is the argument if the argument lies between minus 180 and plus 180? That's what I'm explaining to you in this table. So first number I am taken is 4. 4 means 4 plus 0i, which is on the x-axis. On the x-axis on the positive direction, argument will be 0 because you have to rotate only 0 degrees to reach there from x-axis. So both the places will be 0. Have you written all of you?
Yes, sir.
Now write the next one. 1 plus I.
Yes, sir.
1 plus I. Where will be 1 plus I? Tell me the coordinate for 1 plus I.
1,
Small
0.
diagram.
1, 0, 1 plus 0,
1, 1.
First quadrant. First quadrant.
1, 1. I'll make it a little more bigger.
First quadrant, sir. 1.
Yeah. 1 plus I. So this will be my complex number, Argand's diagram. Now tell me, what is the formula to calculate the argument? Here we cannot do logically. Our formula is tan inverse B by A. First quadrant answer is tan inverse B by A. That is tan inverse. B means, what B stands for? Imaginary part. A stands for real part. So tan inverse of 1. What is tan inverse of 1? 45 degrees. If you write in degree, 45. If you write in radian, 5 by 4. Here also the answer will be the same thing only, no change. Positive angle, no change. Next number is 6i. This I explained to you yesterday also. 6i means 0 plus 6i. Where do you mark 0 plus 6i?
0 plus 6i.
It is 0, 6.
Y-axis.
The point will be somewhere here.
It's
On the imaginary axis. Yes.
0 plus 6. So how much should I rotate to reach from here?
90.
90. So we are not using any formula. If it is on the axis, we are not using any formula. We'll just look at the axis and decide. So you don't have any formula here. So it lies on positive y-axis. So argument of z would be 90 degrees, which you may write in radians, pi by 2 radians. Here also answer will be pi by 2 radians, no change. So when it is on the quadrant, then only formula is required. If it is on the axis, no formula is required. I hope you're understanding.
Yes.
Yes, sir.
Logically, are you following?
Yes, sir.
Don't
Yes,
copy
sir.
from the board. Logically, you must understand.
yes, sir.
Minus root 3 plus I. X is negative and y is positive. Which quadrant? X is
Fourth
negative and x is negative.
Second.
Second.
Sir.
X is negative and y is positive. So this point will be minus root 3 plus I. Okay. So this is the angle that we are talking about. This is the argument. So argument of z in this case, can you tell me the formula? If it lies in second quadrant, what is the formula? Look at
180 plus
3
both have
plus
same formula.
inverse of
You can
tan.
use.
tan inverse b.
So 180 means pi plus tan inverse b by a. The formula changes according to the situation. So pi plus tan inverse, b means imaginary part, a means real part. A negative sign is there. This negative will come outside. Minus tan inverse 1 by root 3. Have you marked negative here? Which angle tan become 1 by root 3?
30 degree.
30 degrees.
3 degree.
So pi minus 30. 30 is pi by 6. Or you can write 180 minus 30, 150 degrees. Or you can write 5 pi by 6. Here also answer will be the same thing only. No change. 5 pi by 6. In the first quadrant and second quadrant, there is no change in the formula for both the case. So what I meant to say is this is also correct. This is also correct. Only you, even if you learn one of them, is fine. Can I remove the first example?
Yes, sir.
Yes, sir.
Okay, I will write with some other color, green. Next point is minus 8. Why I'm taking all possibilities? I'm taking one possibility. Where is minus 8 coming on?
On axis,
Yeah, on the
real
axis.
axis.
So minus 8 plus 0i. Actually, it is minus 8 plus 0i. Yeah? So it is coming on the negative x-axis. So tell me how much should I rotate to reach here?
180.
180 degrees. So argument is 180 degrees. You may call it as pi radian. You may call there also 180 degrees pi radian. Because 180 is there in the within the range. Here it is only minus 180 to 180. Here it is 0 to 360. Okay, next question is minus 1 minus root 3i.
Third quadrant.
Both are negative. -1, -√3i.
Third quadrant, sir.
Yeah, third quadrant. So it will come here. -1, -√3i. Can you read it? I think you may not be able to read this. -1, -√3i. So this is in third quadrant. Now answer, this will have both different answer. If you are measuring this way, look at this. If you are measuring this way, then it is this answer. If you are measuring this way, then this is your second answer. So in this way, if you are measuring, answer is 180 degrees or pi plus tan inverse b by a. If you are measuring this way, minus pi plus tan inverse b by a. So your answer became pi plus, measuring this way, tan inverse b is -√3, a is -1. That became pi plus tan inverse √3. That became pi plus 60 degrees.
Degrees.
That is
5.
4 pi by 3. Whereas this will be minus pi plus tan inverse b by a, same thing. So minus pi plus tan inverse √3. That is minus pi plus pi by 3. That is minus 2 pi by 3. Look at the angle, it's negative. This way measurement they have done, so negative. Both the answers are perfectly okay. Then minus 5y. Do it yourself. Minus 5y.
First one, it's 270.
70
270
degrees. And this will be minus.
-90.
So if it is on the axis, we don't have to do any formula. Just look at it and say the answer. The next number, 1 minus I. I'll remove this, I think. Can I remove this part also?
Yes, sir.
When you are silent, I understand that is no problem. If no sir comes, that means I need to. So this will be in which quadrant?
4.
Fourth quadrant. So this answer will be here, 1 minus I. So you can measure this way or you can measure this way. Yes. If you are measuring this way, our formula is 2 pi plus tan inverse b.
Tan inverse b upon I.
And if you are measuring this way, just directly tan
Tan
inverse.
inverse.
inverse b by.
So now if you replace 2 pi plus tan inverse minus 1 upon 1. 2 pi minus tan inverse 1. 2 pi minus pi by 4. So 7 pi by 4. Here directly tan inverse B is how much? Minus 1 upon 1. So minus tan inverse 1. Which angle tan becomes 1?
45.
45. So minus pi by 4. So that is the answer for it. I think you understood all the cases. Anybody is having doubt in any of the case?
Sir, in the second case, one which is required for JE, I
Yeah.
have little doubt in this one.
Okay. Look at this. The formula is a little bit variation. First and second quadrant both have the same answer. Only third and fourth quadrant you have different answer. Why it is minus 180 plus tan inverse B by A in third quadrant? Why? Because this angle, just look at this. This angle is minus 180. From that, we have to remove this. So that's why minus 180 plus tan inverse B by A. Okay. And whereas in this one, I want only this angle. Automatically B by A is negative because A is positive and B is negative. So automatically
Negative,
that
yes,
minus sign will make it within this quadrant. Is it understood? Any other
Yes,
doubt?
sir, understood.
Yeah.
No, sir.
Just learn even one of them. That's no problem. According to me, you learn this. But your textbook answer will tally only with this answer. Today, when I give you the problem, you can use any method, but textbook answer will tally with this.
Okay, sir.
Okay. Now we come to the next part. Some properties of modulus. Okay.
Sir, I was writing.
You are writing. Which part? This one? Okay.
Yes.
Yeah. Now I'm going to teach you what are the properties of modulus. What can you say if modulus of a complex number is 0? What should be the number? Can there be many numbers? Only one complex number. Which means if z is a plus ib, modulus of z is root of a square plus b square. Which means modulus stands for distance from the origin. This is a modulus. If modulus is 0, which is that point? Distance from the origin is 0. So what should be that point?
Origin.
Origin itself. So z will be 0 plus I. So if modulus of z is 0, the complex number is 0 itself. You don't have to write 0 plus 0. You can just write 0. This is the first property. Second property. What can you say about modulus of z and modulus of z bar? What does z bar stands for?
The inverse.
If this is a plus ib, that is z. What will be z bar?
A minus IB.
A
A
minus
minus
IB.
ib. Where it will be? It will be here.
Yes, sir.
What can you say about this length and this length?
Equal.
Equal.
Both will be root of a square plus b square.
Yes, sir.
This will be root of a square plus b square. This also will be root of a square plus b square.
Yes, sir. B square. Yes, sir.
Both will be equal. Understood for the second property? Conjugates modulus and the numbers modulus will be equal. Third property. If I multiply a number with its conjugate, what answer will I get? Z is a plus ib. Its conjugate is z bar, a minus ib. If I multiply z with z bar,
We get the modulus.
it is a plus ib into a minus ib,
Z itself.
which is a square plus b square It is modulus z square. Am I right?
Yes, yes, sir.
Modulus z is root of a plus b. You square it. So it is modulus of z square. Very important formula. It can also be written as modulus of z bar square because both of them are equal. So whenever you see modulus of z square, immediately your mind should say it is z into z bar. Have you followed?
Yes, sir.
Three properties are clear to you. Next property. This is a very interesting property. Yeah? I want to calculate the modulus of this number 2 plus 3i into 1 plus I into 2 plus 3i into 5 plus 4i divided by, okay, division I'll do later. I want to calculate the modulus of, after multiplying all, I have to calculate the modulus. That means modulus of Z1, Z2, Z3, how much are you feel like? How will I calculate this?
We have to find the individual modulus.
Yes, take the individual modulus and multiply. How much are you have? Did you understand the meaning?
Yes, sir.
So the property is modulus of Z1 into Z2 into Z3, how much ever you have Zn, will be individual modulus multiplication. Each one modulus you calculate and multiply. Even division also same method. Modulus of Z1 divided by Z2. Numerator's modulus divided by denominator's modulus. Have you understood this?
Yes, sir.
Okay. Let me just teach you one problem. Don't write this, okay? Just totally understand. 2 plus 3i into 4 plus 5i divided by 3 minus 2i into 5 minus 4i. This is your z. That is your z. What is modulus of z? So what should I do?
You find the modulus.
Calculate the modulus of this, calculate the modulus of this, calculate the modulus of this, calculate the modulus of this. I don't have to expand it and then multiply by conjugate and calculate. What will be by numerator answer? 2 square plus 3 square into root of
13.
4 square plus 5 square divided by
5
root of
3
square
square.
plus
3
square
square
plus
plus
2
2 square.
square.
into root of 5 square plus
5
9.
square plus 4 square.
Single cancel.
What happened?
Cancel.
This and this will get cancelled. This and this will get cancelled.
One is out.
One is the answer.
Did you understand? Have you got the idea?
Yes,
The modulus of z is 1.
Yes.
Although the complex numbers don't cancel, they don't get cancelled. Where the modulus of this two complex number will be 1. Have you understood this problem?
Yes, sir.
Okay.
Yes, sir.
Do you want to write this? Write it. Example 1. Write it in a different page. Don't write in the same page. Here I have to continue more. So don't fill there. Write a fresh page and write the example 1. I'm going to do sum of the two complex numbers modulus. Each individual modulus, complex numbers modulus, if I add, will they be equal or not? I'll take an example of Z1 is 3 plus 4i. Z2 is, tell me, 12 plus 5i. I am going to add both of them, Z1 plus Z2.
16.
So 12 plus 3, 15, 4i plus 5i.
9.
Now I am calculating modulus of this sum. Root of 15 square plus 9 square. Root of 225 plus 81. Root of 6, 306.
306.
It's not possible.
So which is
Yes,
correct
sir.
now? Yeah, and not perfect root. Let us leave there. Now I am going to calculate each one. Modulus of Z1, root of 3 square plus 4 square, root of 9 plus 16, root 25, fine.
5.
Modulus of Z2, root of 12 square
12 square
plus 5 square. 12 square plus 5
plus
square.
5 square.
169.
169.
120.
13.
13. Check whether
Not.
sum of this two and
13.
this are they equal.
No.
No.
So modulus of Z1 plus Z2 give you root of 306. 5 plus 13 give you 18.
18.
So they both are not equal. Is that clear?
Yes, sir.
Modulus of Z1 plus Z2 and modulus of Z1 plus Z2 are not equal. Now geometrically, if you look at it, this is Z1. This is Z2. Now Z1 plus Z2 is obtained geometrically by drawing a parallelogram. The diagonal of this parallelogram is Z1 plus Z2. Did you follow this?
Yes.
Geometrically, how to calculate Z1 plus Z2? I marked Z1, I marked Z2. After that, I joined the origin. Then I draw a line parallel to the Z1 and another line parallel to Z2. They intersect at one point. That is Z1 plus Z2. This you must have learned somewhere else also. In physics, have you learned this somewhere else?
Oh.
Addition of vectors.
Vectors.
Did the teacher teach you how to find the sum of two vectors?
So vectors happens
Geometrically?
Yeah.
This is the method to find geometrically method. Okay, do one thing. Geometrical method of addition. Give the another page you take. Geometrical method to find sum of two complex numbers. What is the geometrical method to find sum of two complex numbers? Draw the Argand's diagram. Okay. Mark this point. Okay, what I'll do, I'll show you an example. 1 plus 2i and 2 plus 3i. We'll mark this and we'll check what is the answer we are going to get. Okay. So I need up to 5 on it. 1, 2, 3, 4, 5. In this also I need up to 5. 1, 2, 3, 4, and 5. First you will mark 1 plus 2i. Mark 1 plus 2i. X-axis 1, y-axis 2. This is 1 plus 2i. I'm calling this as Z1. This Z1. Then mark 2 plus 3i. 2 here. Oh, this was going. No, I'll at 2 plus I will take. Then only I can draw properly. I'm changing this number. 2 plus I. Otherwise, my diagram will have a little difficulty in drawing. X coordinate is 2, Y coordinate is 1. Let me use some other color. I'll use black. This is Z2. When you add Z1 plus Z2, I get 3 plus 3i. Do you agree with this? 1 plus 2 give you 3. 2i plus I give you 3i.
Yes.
Yes.
Now check whether, where's this number somewhere here? This is 3 plus 3i. This is 1 plus 2i. This is 2 plus I. Now you will notice, now I'm going to do the geometrical method. What the geometrical method is, draw a line parallel to this black line passing through Z1. Something like this. Later that it should pass through this. I am not looking at this. I have just drawn a line parallel to this passing through Z1. Same way, I am going to draw a line parallel to OZ1 passing through Z2. It will be something like this.
Exactly parallel.
Yeah. And you will notice that this both parallel lines will automatically intersect at 3 plus 3i. Understood? Actually, I was supposed to draw without showing you. Imagine this 3 plus 3i is not known to you. First, what I did, I drew a line parallel to OZ2 passing through Z1.
Yes.
Another line I drew parallel to OZ1
OZ1.
passing through Z2. Then I am going to calculate what is there, where do they intersect? They will intersect at 3, 3. So this is 3 plus 3i. That is exactly the sum of Z1 plus Z2. So this particular line, this particular line? This one is nothing but Z1 plus Z2. Automatically it will become Z1 plus Z2. Have you understood?
Yes, sir.
Everybody followed?
Yes, sir.
Okay. Now look at this diagram. What is modulus of Z1 plus Z2 and modulus of Z1 and modulus of Z2 sum? Which will be greater? They are not equal, you agreed. Which will be greater? Will this length,
Modulus of Z1 plus Z2.
will OP will be more or OQ plus OR will be more?
OQ plus OR.
OQ plus OR will be more. So this will be greater. They can be equal. If they lie on the same line, Z1 and Z2 are lying on the same line, Z1 and Z2 lie on same line. Then modulus of Z1 plus modulus of Z2 will be equal. They both will be equal. Not only same line, their argument should be same. Then only this will happen. Okay?
Yes, sir.
Is this concept geometrical method, is it clear to you?
Yes, sir.
Yes, sir. Yes, sir.
Hey students, you have to take care of this part. How do you find the sum of two complex numbers? And that's how I can prove that modulus of Z1 plus Z2 is less than. So when they are equal, Z1 and Z2 should lie on the same line. Time is over. Okay.